We present an interactive design system that allows non-expert users to quickly create inflatable structures such as foil balloons, decorative items, or furniture. In contrast to common rubber balloons, inflatable structures are made from flat patches. Manual design of such structures is difficult since the user has to anticipate and invert the effect of pressure on the design. Our method greatly simplifies this task by automatically computing pattern shapes, but leaving the user in control over aesthetic considerations. The workflow of our system aims to be simple and intuitive. As input, we take a 3D model representing the 3D target shape. The user provides an initial guess for the patterns by drawing seams on the 3D model. Our physics-based optimization computes optimal patterns such that the inflated shape matches the target as closely as possible. Our system is fast enough to allow interactive exploration of seam layouts. The designs produced by our system are feasible and can be used to fabricate inflatable structures. In the following, we will demonstrate the design process in more detail. The user starts with a selected target shape and incrementally builds a seam layout that partitions the target mesh into a set of segments. We provide a simple spline tool for this purpose that connects seam points through approximately shortest paths on the surface. The user can modify the shape of the seams by dragging on control points. Once done, the patterns are flattened in order to obtain an initial guess for the 2D pattern shapes and the inflated model. The pattern shapes are then optimized to resemble the target shape as closely as possible. The user can iteratively revise and edit the system layout to explore various designs. Our interface also allows us to easily place internal connections that significantly expand the design space. For this purpose, the user first selects a number of seam segments forming a closed loop. This seam loop then defines the boundary of the new internal connection. As shown in this example, internal connections allow the user to model sharp feature curves that delineate, for example, the muzzle of the fox. Internal connections can also be used to prevent concave features from popping outward due to pressure forces, as can be seen in the fox's ears. We used our interface to design a diverse set of examples. For 3 of these examples, we also fabricated physical prototypes. Thank you for your attention.